Morning.
Morning. Where's pizza at?
Yeah, it's on the oven.
Oh. Do you want me to save you one of these pieces?
No, not necessary. Yes, Taryn.
Did you get my email about what happened to my Amplify?
Yeah, the same thing was happening to mine, so hopefully we can try here again.
Okay.
How's everyone today? Thumbs up? All right. When we start here in another minute, we're going to start continue with the interactive phase change gizmo. So if you want to open that up. Skylar.
If I happen to like get cut out or something, that's because we're at our grandma's house using our dad's hotspot because they're putting in our septic system today.
Oh, fun.
So yeah.
All right. All right, open up the interactive. I'm gonna share my screen so we can continue with that activity. Any questions before we start? All right. I'm gonna start on activity B. Okay, you guys good? All right. So activity B, get the gizmo ready, click reset, select micro view, set ice volume to 0, set add remove heat to 0. And then it says set the water temperature to 0, click play. All right, so let's get that set up here. Ice volume to 0. View. Oh, to 0. I think that's all right. So if we click play on that, okay, what did you notice on that? Anybody?
I think you sound rabid almost. Just rabid for some brawlers, come here! Dude, we've got nothing around us.
Then I just wasted all my ammo. So that's unfortunate. It's okay.
We can't hear you.
Rico here.
Keaton. That was Keaton.
Mr. Richards, we still can't hear you.
You're muted, kid.
Okay, who's playing like Call of Duty or whatever? Zane, is that you?
No!
Keaton?
Mm-hmm.
Yeah.
Okay, so Keaton, what'd you observe happening?
Okay, so whenever I hit micro view, I observe that all of the blue little blobs are like, they're all bouncing around and they're in only groups of 2. They aren't all together. And then for the molecules in the water, they're all not even, well, they bump into each other, but they don't clump up together and mainly stay away from each other.
Okay, so there's 2 things on that. We're gonna first set it to 0 and then set it to 100. Is there really anything happening?
No?
No.
It's cold in here.
All right, click reset. The mean molecular speed of the water molecule is displayed below the container. Set water temperature 0. Add removed energy to 400 and click play.
Mr. Richards,
Yeah.
do we have that worksheet or whatever you were just typing on?
Yeah, it's on your Google Classroom.
Okay.
And I just lost the worksheet here. Okay, set water temperature to 0. Oh. So you look at down here, the average molecular speed. Increased up to a 662. And now it's staying constant at 662. So how does the speed of the water molecules change as they're heated? They increase.
We're on 2.1, right?
Okay, we're on the Explore Learning gizmo, Zane, like we were doing yesterday. This isn't Amplify, this is Explore Learning.
Apparently you gotta sign up.
Yeah,
Wait,
we should have already signed up.
Yep, I already did. There we go.
Okay, does the mean molecular speed change as much as the temperature as the water heats up? So if we watch the temperature and the speed, right? They're both increasing about the same rate, aren't they?
Yeah.
Right. How is temperature related to the motion of the molecule?
Wait, where is that?
We're just continuing with the worksheet we started yesterday, or I thought we started yesterday. Were you not, were you playing like Call of Duty while we were doing this?
No! You can't play Call of Duty.
Or Fortnite?
No. I don't like Fortnite.
That's because you're bad at it.
Huh? Sorry, I couldn't hear you. Mr. I don't play games.
Okay, so temperature is a measure of its speed. Now it says click reset, set the water temperature to 20, ice volume to 50.
Where is this? Where is that?
Where's what?
The thing you're typing on.
Hey,
I
it's
don't
The
like-
worksheet, Zane.
Zane,
know.
it's on Google Classroom.
Oh, I was looking at Google Docs for some reason.
Well, you hopefully started this yesterday, but obviously not. So all the answers we went over yesterday in class, you were like in a daze and didn't do any of that?
Oh, I was still listening, okay? I was listening. Oh, there it is.
All right. Anyway, click reset, water temperature to 20. Ice volume to 50. Add remove heat to 0. And click play. Our ice cube is getting smaller, isn't it?
Yeah.
Water volume's increasing, ice volume's getting smaller.
So is the temperature.
And our temperature's dropping. Hey, how do the molecules in the liquid interact with the molecules in the solid?
Where are you? Oh,
Can
found
you
it.
find us?
Yep, found it.
Hey.
What are you typing? Ice molecules transfer to water. Ice molecules.
Okay, click reset, set water temperature to 100, ice volume to 50, and click play. All right, I can't remember. Water temperature 100, ice volume to 50. Stop moving.
I shrunk really fast.
Yeah.
And bye-bye.
So it's much faster. Okay, based on what you learned, explain why you think phase change occurs. It's possible to discuss your theory with your classmate. So why does a phase change occur?
That's the temperature. What?
Why does it occur?
Because the temperature changes, or like, yeah. That's all I
The
got.
molecules are moving in different ways.
So the temperature makes the molecules move what?
In different ways, or like faster or slower.
Okay.
I don't know how to put it.
Okay, so if you increase the temperature, the molecules move faster, and then vice versa. If you decrease the temperature, they're going to slow down. Hey, use your theory to explain what happens at the molecular level in each of the following situations. Ice is warmed to the melting pot. I'm sorry, melting point. So what's going to happen to the temperature?
It will stay the same during the change and then heat up after the change.
Yeah, the ice will stay the same temperature until all is melted. And what temperature does that happen at? What temperature does ice melt at?
0 degrees Celsius, 32 degrees Fahrenheit.
Okay, water is warmed to the boiling point. What's going to happen to the water?
It's going to evaporate.
Okay, but will it heat up?
During the change, it'll stay the same and then it will
Okay,
heat
but
up.
it's not during the change. It says water is warmed to the boiling point.
Then it's gonna the temperature is gonna increase.
And what's the boiling point? Just Celsius.
100 degrees Celsius.
Okay, water is cooled to the freezing point.
100 degrees.
Temperature? Kobe?
0 degrees Celsius or 32 degrees Fahrenheit.
Hey, extend your thinking. Click reset. Set water temperature to 0. Ice volume to 0. Add remove heat to -400. Click play until all the water freezes. What volume of ice is created from 200 cubic centimeters of water? 0, 0, and -400. Water levels going down. Ice is increasing. Okay. Now we have no water left. It's all ice. So what volume of ice would be created from 200 cubic centimeters of water?
Volume of ice.
We started with 200 centimeters of water. And we let it all change into ice.
So 200.
Is it though?
Doesn't ice get bigger?
Wouldn't it be 0?
Look how much ice we formed. We started with 200 water. When we're done, we have 217, right? We have more ice.
Mr. Richards, is it okay if we put 217.4 for it?
Yeah.
Okay.
Okay. 217.4 milliliters or a cubic centimeter, same thing. Okay, so why do water pipes sometimes burst in the winter? What happened to the ice, right? It took up more volume.
The ice expands
Okay.
from water. And then
All right. Activity C, click reset, ice volume to 0, set the altitude to 5,000 meters. Ice volume to 0. Okay, altitude locations, vertical distance across above sea level. How does altitude affect phase change? Form a hypothesis. At altitude, as altitude increases, air pressure decreases. How do you think lower pressure will affect the following? So freezing point. At a higher altitude, what's going to happen to the freezing point? You think it's going to go up, stay the same, or go down?
Yeah, increase.
Increase? I don't know how you want to mark that, if you want to bold it or change the color of it, or underline it. Melting point. High in the mountains, we think. Is the melting point going to go up, go down, stay the same?
Go down.
decrease.
And boiling point?
Increase.
Think it's going to increase? Okay. Okay, so what we're saying here is if we go to the mountains, if we go to Colorado or whatever, the freezing point's going to be lower. So ice is going to freeze somewhere below 0 degrees. At 0 degrees, it'll still be water. Right? Melting point is going to, freezing point is going to increase. So the freezing point will be like, maybe like 1 degree it would freeze. But the melting point would decrease. So instead of 0 degrees, now the ice would melt at like -1. And boiling point is going to go up, so it's going to be harder to boil water in the mountains. We're good with that? Okay, use the gizmo to find freezing, melting, and boiling points of water at 5,000 meters. So we want to look at the freezing point first.
Freezing.
And look at the freezing point here. -3.8.
How do you do the degree sign?
Yeah, option 0.
Option 0.
Yeah. Right. Melting point. Do we already know the melting point from what you already learned?
Yeah.
If you know the freezing point, what's the melting point?
The same
The
thing.
same. Right. So it still has to be -3.8. Okay, boiling point in the mountains. Start with water temperature 0. We're going to increase the heat. We're going to keep our altitude at 5,000 meters. And we're going to boil that water off. We're going to get as high as it can. Do it a little faster here. Water's heating up, not boiling yet. Our water volume is still at 200.
There it is.
There it is. So the temperature at boiling point is only 83 degrees. Oops. Okay, so the freezing point and the melting point dropped, decreased, and so did the boiling point, didn't it?
Mm-hmm.
All right. You shouldn't have too much left to do on that worksheet. We can go ahead and finish it up sometime today or tomorrow. That would be amazing.
Yes, sir.